In this video, I am going to give general introduction of organic chemistry. First topic in basics of general organic chemistry. First topic, general introduction. This is the first topic. In this video, some introduction regarding organic chemistry. First of all, what is organic chemistry? What is the definition of organic chemistry? Organic chemistry is a branch of chemistry which deals with preparation, structure, properties of organic compounds. Simply we can say, what is organic chemistry? Organic chemistry is a branch of chemistry which deals with structures, nomenclature, synthesis and properties of organic compounds. I am going to write definition. Organic chemistry is a branch of chemistry which deals with structures, synthesis, and properties of organic compounds. Organic compounds, synthesis, properties, structures will be described in organic chemistry, different organic compound. Then what is organic compound? Organic compound primarily consists of carbon and along with carbon, hydrogen. Carbon also contain hydrogen, oxygen, sulfur, halogen, phosphorus. These atoms may be present along with carbon. Organic compounds primarily consist of carbon. Along with carbon, organic compound may contain hydrogen, oxygen, nitrogen, sulfur, phosphorus and halogen atoms. So, definition of organic compound. Organic compounds primarily made up of carbon atoms often combined with hydrogen, halogen, nitrogen, oxygen, sulfur and phosphorus atoms. Organic compounds primarily made up of carbon atom often combined with hydrogen, halogen, nitrogen, oxygen, sulfur and phosphorus atoms. This is organic chemistry. Next, organic compounds uses. What is importance of organic chemistry? Organic chemistry play an important role in the understanding biochemical processes, biological reaction and for the development of pharmaceuticals and for the creation of synthetic materials. These are general uses of organic chemistry. So, what is the importance of organic chemistry? Organic chemistry plays an important role in understanding biological reactions. Biological reactions for development of pharmaceuticals, and creating synthetic material. Etc. So, what is importance of organic chemistry? Organic chemistry is very important to understand biochemical reaction, biological processes. So, the process taking place in living organism, plants and animals. To understand those biochemical reaction, organic chemistry is very important. Next, what? For the development of pharmaceuticals, for development of chemicals, for development of medicine, drugs, like that. Next, creating synthetic material, to create polymers, to create different type of synthetic material, organic chemistry is very, very important. Okay. Next, we have to talk about some classification regarding organic chemistry. For the first time in 1605 year, the scientist Lemery classified the natural chemical compounds into three categories. They are compounds of mineral origin, compounds of vegetable origin, compounds of animal origin. So, scientist Lemery, so known compounds, known natural compounds, chemical compounds classified into three categories. So, at the time of Lemery, there is no term like organic chemistry, there is no classification like organic, inorganic. So, he classified, for the first time, he was classified the known natural chemical compounds into three. They are compounds of mineral origin, minerals నుంచి origin అయినటువంటి compounds, and second one compounds of vegetative origin. The compounds originate from plants, and the compounds of animal origin. Three categories. So, for the first time, scientist Lemery in 1605 year classified natural chemical compound. At the time of Lemery, there is no synthesis of chemical compound. Chemical compounds are only obtained from nature. So, synthesis is unknown at the time of Lemery. So, he was classified natural chemical compounds into three classes. This is earlier classification, three classes. They are compounds of mineral origin, compounds obtained from the minerals. Next, compounds of vegetable origin. Means compounds obtained from plants. Next, compounds of animal origin. Compounds obtained from animals. So, he was classified natural chemical compounds into three. Next, if we see next classification or the term organic chemistry. The term organic chemistry is given by Berzelius. He was used for the first time term organic. Organic అని term first time use చేసింది scientist Berzelius. Okay. So next Berzelius proposed a theory, vital force theory, we are going to discuss. So first the term organic was first used by person named Berzelius. Scientist Berzelius used the term organic. Okay, so in his theory, vital force theory, according to vital force theory, proposed by Berzelius, organic compounds are the compounds from living organism. The compounds from living organism. They cannot synthesized in laboratory. What does it mean? Organic compounds from only living organism, they cannot be prepared in laboratory. So according to vital force theory was proposed by Berzelius. But after synthesis of urea, this vital force theory lost its significance. Because so according to vital force theory, organic compound cannot be synthesized in laboratory, but urea was prepared by a person, Friedrich Wöhler. He was prepared urea. So after synthesis of one organic compound in laboratory, vital force theory lost its significance. Okay. Vital force theory, or you can call vital force theory, lost its significance after synthesis of urea. So Berzelius proposed vital force theory in 1807. So for the first time, Lemery 1605 classified the element into 3 categories. Next, Berzelius used the term organic in 1807. Okay. Next, vital force theory lost its significance after synthesis of urea. Urea was prepared in laboratory by scientist Friedrich Wöhler in 1828. So urea is first synthesized organic compound organic compound in laboratory in 1828 by scientist Friedrich Wöhler. He is considered to be father of organic chemistry. Okay. Ammonium cyanate, it's some inorganic compound called ammonium cyanate. Ammonium cyanate upon heating forms urea. Ammonium cyanate upon heating forms urea. So this process, what is the process takes place in conversion of ammonium cyanate to urea is tautomerism. So this is called urea. What is the IUPAC name of urea? Urea IUPAC name aminomethanamide. Aminomethanamide is IUPAC name of the urea. Okay. So if you talk about first synthesized organic compound from its elements in laboratory, that was acetic acid by Kolb, scientist Kolb. So generally compounds can be prepared from other compounds or from elements from the standard states. So this is the compound urea first time prepared. It was prepared for the first time from another compound. Now I am talking about the compound which is prepared from its elements. The compound which was prepared for the first time from its constituent elements is acetic acid. Acetic acid was prepared by scientist Kolb. So I can write first synthesized organic compound from its elements in laboratory is acetic acid. By scientist Kolb. Next, second synthesized organic compound from its elements in lab is methane, CH4, formula CH4, compound methane, by scientist name Berthelot. Okay, so first synthesized organic compound from laboratory is urea. First synthesized organic compound from its elements is acetic acid. Second synthesized organic compound from its elements is methane. From its elements, first compound acetic acid, second compound methane. Acetic acid prepared by Kolb scientist and methane prepared by Berthelot. First synthesized organic compound not from elements, from other compound, that is urea by Friedrich Wöhler. Friedrich Wöhler was considered to be father of organic chemistry. Okay, right. Next, carbon form innumerable number of innumerable number mean 10 million 10 million mean 1 crore. So 10 million organic compounds. 10 million organic compounds are identified yet. Carbon form that much number of compounds, unlike other 14 group elements, other elements of periodic table, because of its characteristic property. Carbon form that much number of compounds, unlike other elements, because of its characteristic properties. What are characteristic properties of carbon? Carbon has covalency 4, and carbon can form multiple bonds. It has a tendency to form multiple bonds, and carbon has highest catenation capacity in periodic table. And if you see compounds of carbon, they are covalent compounds made up of covalent bonds, sigma bond, pi bond. They are participate in isomerism. So these 4 property makes carbon to form that much number of compounds. So I am writing that point. Carbon form such number of compounds due to its characteristic property, characteristic properties. What are characteristic properties of carbon? Carbon covalency is 4. Carbon can form multiple bonds, double bonds to triple bonds are said to be multiple bonds. Carbon can form multiple bonds with other carbon, not only with other carbon but also with oxygen and nitrogen. Carbon can form multiple bonds. Next, carbon has highest catenation capacity. Carbon has highest catenation power. What is catenation? The self-linkage of an atoms to form long chains of different number. Long chains it can form. Carbon can form long chains of different lengths. So 10 carbon, 12 carbon. It can form long chains. They may be straight chains or branched chains. It has the ability to form such long chains. That is called as catenation. Next is what? Organic compounds participate in isomerism. Organic compounds show isomerism. These 4 properties makes carbon to form such a number of compounds. This is general introduction of organic chemistry. So in next video I will do the tetravalency of carbon and shapes of organic molecule. Hope you understood. Thank you.